Yesterday we dealt with quadratic functions. We stated that a quadratic function was in the form of f of x equal ax squared plus bx plus c. And that this function, the set of points, make up a parabola. What we had to do is graph some of these quadratic functions. Are there any there you'd like to see worked?
Could you do number one?
Can I do number one? You bet I can do number one. Number one says that f of x is equal to x squared minus 5x plus 4. This is number one. F of x equal x squared minus 5x plus 4. Now, we know we're going to have a parabola. We know this parabola is going to have a minimum. The way we know that is by the coefficient of x squared. Remember yesterday we said that if the coefficient of x squared is positive, it has a minimum. If it's negative, it has a maximum. Well, the coefficient of x squared is positive 1. Now to find the x value, the minimum point or maximum point, the x value is always equal to negative b over 2a. So that would be a negative 5, which is positive 5, over 2 times 1 is 2. What we get for the x value of the minimum point is 5/2. We now select the other x's we plan to use. I told you, since we're selecting them, select whole numbers. And so that you get a nice symmetrical picture, I select the 2 whole numbers immediately to the right of this, the 2 whole numbers immediately to the left. Well, the 2 whole numbers to the right of 2.5 are 3 and 4. The 2 whole numbers to the left of 2.5 are 2 and 1. And these are the x values that we want to use. What we have to do now is find their corresponding y values. So I want to work it right to left, save the fraction for last. F of 1. That says go back to f, every place you have an x, put in 1. Well, I have 1 squared minus 5 times 1 plus 4. Well, that gives us 0. So f of 1 is 0. F of 2. That would be 2 squared minus 5 times 2 plus 4. Well, that gives us 4 plus 4 is 8 minus 10. Well, that gives us a negative 2. So f of 2 is equal to negative 2. F of 4. That would be 4 squared minus 5 times 4 plus 4. Again, I emphasize this is all arithmetic. You evaluate this, you come out with 0. So f of 4 is 0. F of 3. That's 3 squared minus 5 times 3 plus 4. Well, that's 9 plus 4 is 13, and a negative 15 gives us a negative 2. So f of 3 is negative 2. Notice yesterday, in our last lecture, we said that any time the x value of the minimum or maximum point is a whole number or a half, you will have this symmetry. You do. These two and these two are exactly the same. Now you see, one of your problems, the x value comes out to be, I believe, negative 7/4. So you don't have that symmetry. You get all different numbers here. Okay? Only if this is a whole number or a half. You select the 2 whole numbers to the right and to the left, you'll come out with this. Now that leaves us f of 5/2. And for some reason, anytime we have fractions, there is trouble. All we're doing is finding f of 5/2. Every place we have an x, put in 5/2. Well, that gives us 25/4 minus 25 over 2 plus 4 over 1. The LCD here would be what? 4. That gives you 25/4 minus 50/4 plus 16/4 is a negative 9/4. Okay? So there's our chart. We now have to find the intercepts. Well, the y-intercept is always nice and easy. It's 0, c. 0, 4. Remember, the y-intercept is always 0 constant. The x-intercept, well, it's a little bit more work.
We have them.
I know we do.
Oh.
That's what it was. To find the x-intercepts, we let y equal 0, so we have 0 is equal to x squared minus 5x plus 4. We factor this. I told you these are all factorable. Set each factor equal to 0. Solve them, you get x equal 1, x equal 4. So your x-intercepts are 1, 0, 4, 0. And so there are all the points we need in order to draw a decent sketch. So now we come over here. Now, the first point we're going to do is, the first thing we're going to do is locate all these points from the chart. The first point is 5 halves and negative 9 fourths. 5 halves, well, you approximate. 5 halves, that's 2.5. And then negative 9 fourths, well, that's negative 2 1/4. Well, if you have graph paper, you'll have these grids, so you'll be able to approximate better than I can on the board. In fact, much better. Next point is 3, negative 2, and we have 4, 0. We have 2, negative 2, we have 1, 0. And there are all the points from our chart. Our y-intercept is 0, 4. Our x-intercepts are, well, we have them already, 1, 0, 4, 0. So there are the points you need. You now play follow the dot. And there is the parabola. Quadratic function f of x equal x squared minus 5x plus 4. Okay?
How come we don't name the parabolas?
What's that?
Why don't we name the parabolas?
You could.
It's not necessary.
Not necessary. Okay? Now, so far, we know how to make two types of geometric figures. The first type we went into was a line. And the general form of a line was ax plus by equals c. Anytime all your variables is first degree, all your variables are first degree, that's a line. By first degree, I mean the highest exponent used for the variable. Notice all our variables, the highest exponent we use is 1. This is always a line. Example, 3x minus 4y equal 15. Line. We know how to draw the picture of the line. The second geometric figure we talked about was a parabola. And the general form of a parabola was y equal, or f of x, ax squared plus bx plus c, where a is not 0. What we're saying here, in order to have a parabola, we have an x and a y. The y is first degree, the x is second degree. Anytime you have an equation where the y has the highest exponent is 1, while the x highest exponent is 2, it is a parabola. Quadratic function. It's a parabola. General form, well, we just got done working with these. Y, or f of x, equal x squared plus 6x plus 8. Parabola. Now today, we're going to talk about 5 more geometric figures. 5 more. But all 5 of them will come out of the general form of ax squared plus by squared equal c. ax squared plus by squared equal c. Notice here both x and y are second degree. The highest exponent for x is 2. The highest exponent for y is 2. Both x and y are second degree. Now, the first geometric figure we can get out of that is the circle. Circle. Everyone knows what a circle is. Well, when do you get a circle? You get a circle when A, B, and C have same sign. And A is equal to B. A, B, and C have the same sign. A is equal to B. Example. X squared plus y squared equal 25. Notice, A, B, and C have the same sign. They're all positive. A is equal to B. The coefficient of x squared and the coefficient of y squared are the same. Circle. Another example. 4x squared plus 4y squared equal 9. 4x squared plus 4y squared equal 9. This is a circle. A, B, and C have the same sign. A is equal to B. Okay? Suppose I have 3x squared minus 3y squared is equal to 11. Is that a circle, Lynn?
No.
No, it isn't.
Different sign.
Everybody see why it's not a circle? In order to be a circle, A, B, and C must have the same sign. Well, they don't. It's not a circle. Okay? Okay, we identified x squared plus y squared equal 25 as a circle. So what I like to do is I like to make the sketch of it. I already know what it looks like. It's a circle. So I want to make the sketch of this circle. And the way we're going to do it is we're going to do it by the intercept method. We're going to find out where this curve crosses the x-axis, where this curve crosses the y-axis. Now, so let's take a look. When it crosses the x-axis, what's true? Well, 0. So I come out with x squared is equal to 25. What would x equal? Remember, anytime you get plus or minus. Very good, Tony. Plus 5, minus 5. And that's where it's crossing the x-axis. We now want to know where it's crossing the y-axis. Well, since it's a circle, it should be the same place, right? But when it crosses the y-axis, x is 0, so we get y squared equal 25. Y would equal plus 5, minus 5. And there are your points. It's enough points to make a sketch. If you want more points, you plug them in and find let x equal 2, find out what y is. But this is not enough points. Remember, it's a circle. It's not a square, a rectangle, rhombus, whatever. It's a circle. So you draw the circle. Okay. So in order to sketch the circle, once we have identified it, we do it by the intercept method. We find out where the curve is going to cross the x-axis, where the curve is going to cross the y-axis. We know what the curve looks like. It's a circle. Everyone's familiar with a circle. Let me draw it. Let's try the second one. You sketch the second circle I have on the board. 4x squared plus 4y squared is equal to 9. Okay, let's take a look at this. Again, we're going to do it by the intercept method. We have 4x squared plus 4y squared equal 9. We're going to graph this. Well, we know that when at any point on the x-axis, y equals 0. So when it crosses, this curve crosses the x-axis, y has to equal 0. So you lose the y term. So what you have is 4x squared equal 9. We had this exact problem when we have pure quadratics. 4x squared equal 9. That means x squared is equal to 9 over 4. X would equal plus or minus 3 halves. Well, that's 1 1/2. That's plus 1 1/2, negative 1 1/2. Now we want to find out where it crosses the y-axis. What's wrong, Lynn?
I didn't say you said it was 9/4.
Yeah. Yeah, 4x squared equal 9. We divide both sides by 4. We get x squared equal 9 over 4. We do the same thing for the y's. Because when it crosses the y-axis, x equals 0. So you come out with 4y squared equal 9. Y squared equal 9/4. Y has, well, it's a circle. It has to be true. Here we go. We now connect these points, draw our circle. Okay? I'd like you to turn to page 268. 268. At the top of page 268, there should be 16 problems, 16 equations. What I'd like you to do is I'd like you to go through those equations and pick out the ones that are circles. Pick out the equations whose graph represents a circle.
One through 16.
Yeah, 1 through 16. There's 16 problems there. 16 equations. I'd like you to find out how many of those 16 represent circles.
I should make up 16 different ones, right? To avoid copyright infringement.
Yeah. Okay, Karen, how many did you get are circles?
3.
3. Which 3 did you find that were circles?
1, 2, and 3.
1, 2, and 3. Does everybody agree 1, 2? No. Look at 3, Karen. I don't have a book.
Oh, okay. 1 and 2.
1 and 2. You see, A, B, and C and 3 have the same signs, but A doesn't equal B, so it's not a circle. Only 1 and 2 are circles. Those are the only 2 of those 16 That's graph is a circle. Okay, now using the same formula, ax squared plus by squared equals c, we can come out with an ellipse. Ellipse. Does everyone know what an ellipse looks like? No? Looks like my circles. It's flattened out. It's an oval shape, egg shape. Oval, elliptical. Okay? When do you have an ellipse? Well, you have an ellipse when A, B, and C have same signs. And A does not equal B. A, B, and C have the same signs, but A does not equal B. Example of that. Well, 4x squared plus 9y squared equal 36. Notice, A, B, and C have the same signs. But A does not equal B. The coefficient of x squared does not equal the coefficient of y squared.
Is that 9y squared?
Yeah, that's 9y squared. Another example. 25x squared plus y squared equal 100. This is an ellipse. A, B, and C have the same sign. A does not equal B. Okay? So again, to sketch an ellipse, we do it by the intercept method. Okay? So we have, I'm going to graph the first one, 4x squared plus 9y squared equal 36. We're going to do it by the intercept method. Well, when it crosses the x-axis, y is 0. So if y is 0, we come out with 4x squared equal 36. That means that x squared would equal 9, and x would equal plus or minus 3. So this is going to cross the x-axis at positive 3, negative 3. We now want to find out where it crosses the y-axis. Well, when it crosses the y-axis, x is 0. So we have 9y squared equal 36. Y squared would equal 4. Y would equal plus or minus 2. So it's going to cross the y-axis at plus 2, minus 2. Now, as again, we're making a sketch. That's all we're doing. You now connect the points up, and you have your everyday football. Okay? See how nice and easy that is? See how important the x and y intercepts are. And that's why I told you, it's so important. Every point on the x-axis, y is 0. Every point comes in play all the time if you go on in math. Okay, I sketched the first one. I'd like you to sketch the second, which is 25x squared plus y squared equal 100. Okay, again we're going to graph this by the intercept method. First of all, we want to find out where it crosses the x-axis. Well, y is 0, so we come out with 25x squared equal 100. That means that x squared would equal 4, x would equal plus or minus 2. Plus 2, negative 2. Now we want to find out where it crosses the y-axis. Well, x is 0, so we come out with y squared equal 100. Y would equal plus or minus 10. Minus 10, plus 10. You now make your graph. Back to page 268. Of those 16 equations, find the ones which represent ellipses. How many, Patty?
I got 6.
You got 6. I got 6. Let's hope they're the same 6. Patty, which ones?
3, 4, 5, 6, 11, and 12.
Beautiful. All those are ellipses. Those are the only ellipses on the page. Okay? Now, in sketching, these are the only 2 of the 5 that we're going to have today that you are responsible for sketching. Just the circle and the ellipse. You see how nice and easy they are. Now, the next type of figure we can have from this equation, ax squared plus by squared equals c, is called a hyperbola. 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 Now, I'm sure that most of you do not know what a hyperbola is. Well, all it is 2 parabolas facing each other. That's all it is. And they can be vertical parabolas, that type, or they could be horizontal parabolas of this type. Okay? Now, when do you have a hyperbola? Well, A and B have opposite signs, and C does not equal 0. An example for a hyperbola. 4x squared minus 3y squared equal 11. This is hyperbola. Notice A and B have opposite signs. And C is not 0. Another example. X squared minus y squared equal negative 3. This is a hyperbola. Again, A and B have opposite signs. C is not 0. Hyperbola. Back to 260.